Welcome to my kcse revision channel. Teacher James Marita, Grigol Boys High School. Kindly subscribe my channel. Click the notification bell such that you get notified once I upload a new video. Today we are looking at chemistry revision, the last topic in Form 4, that is radioactivity, and we want to look at some of the questions from this topic of radioactivity. So in radioactivity, there are so many things you need to study there. You need to have a radioactive graph, so you practice on how you are plotting a radioactive graph. Then we have the radioisotopes. Normally there are 3 of them. We have the alpha particles, we have the beta particles, and then we have the gamma radiation. So follow that diagram, you see the deflection property, the penetrating property, and also the ionizing powers. And also in that case now, you make sure that you know the differences between the nuclear fission and the nuclear fission and fission. So make sure you know those differences. And of course, you know if you have been given a certain table, the count rate per hour, are you able to be able to plot a radioactive graph, and you are able to calculate the half-life from that particular graph. So today, let us look at some of the calculations which are being set from this radioactivity. So the count rate, we have one question here. The count rate of a nuclide. The count rate of a nuclide fall from the count rate of a nuclide fall from 200 counts per minute. They fall from 200 counts per second to 12.5 counts per second. In how many minutes? In this case, in 120 minutes. So calculate the half-life period of the nuclide. Half-life is the time required for an element to drop a half of its original mass. So how do you calculate this half-life period from here? It is just very simple here. I want to use a very simple method, a very simple technique that will make everybody to understand how you are supposed to calculate any questions on this half-life. So first of all, we have the original count rate, it was 200. So this one dropped from 200 to 12.5. So there are 2 things that you need to consider. You consider the count rate from 200 to 12.5. And in this case, we are talking about a half-life period, a time required for an element to drop a half of its original mass. So we need to drop a half by a half by a half by a half until we reach at the 12.5. In that case now, you need to get the number of half-lives, the total number of half-lives. So we can calculate the total number of half-lives here. So we have, first of all, from 200 to 12.5. This one will give us the total number of half-lives. So we start from this 200 here. So we have 200. A half of 200 is equivalent to 100. Then we have hatujafika kwa 12.5. So a half of 100 is 50. But we are far away from 12.5. A half of 50, this one is 25. We are far away from 12.5. And a half of 25, this one is giving us, this is as 12.5. So we drop from 200, a half by a half by a half, until we reach where we have the 12.5. In that case, now we are getting the number of half-lives. So we have 200 divided by 2 because it is a half. 200 times a half or divided by 2, we are getting 100. 100 divided by 2, we are getting 50. 50 divided by 2, we have 25. 25 you divide by 2, we have 12.5. So what is the number of half-lives? So here we have number of half-lives here So we have the number of half-lives. The number of half-lives is equals to be 1, in this case 2, then we have 3, then we have 4. So the number of half-lives here is equivalent to 4. So we have 4 half-lives. Now our question we have to calculate the half-life period. So to calculate the half-life period, so half-life period here, so we have a half-life period, a half-life period is equals to P. We have 120. The time for we have the rate of the nucleides in this third case here now. So in 12 seconds, in 130 seconds. So it might be in 120 minutes. It might be number of years, number of minutes, number of hours. So you take this 120, you divide it by the number of half-lives. So this one will be 120, you divide by the number of half-lives here is equivalent to 4. And this one, in that case, if you calculate like this one here, so the half-life period is equivalent in this case to 30 minutes. So we have that one as 30 minutes. So what you need to understand here, that you are able to calculate the half. So we have 200 to 12.5. How many halves do we have there? So if you calculate a half by a half by a half, until you have 12.5, that one will give us a total number of half-lives. Then the total number of half-lives now divided by this number with the counted per second. The counted per second in this case, which is equivalent to 120. You have now a half-life period is 120 divided by 4, and this one is giving us 30 minutes. So after 6 hours, the count rate of a nucleide, fell from 240, so we have 240 to 15 counts per second. So we have 240 to 15 counts per second in the Geiger-Miller tube. So those people are doing physics, you will understand what is the Geiger-Miller tube is. So calculate the half-life period. So to calculate the half-life period here is very simple. First of all, from 240 to 15, how many halves do we have there? In that case, now we calculate the number of half-lives. So here we have number of half-lives. Now we start from 240. When you divide this one by 2, this one will give us 120. Still, we are far from 15. You divide this one by 120 divided by 2. If you divide that one by 2, it's giving us 60. So if you divide 60 by 2, this one is giving us 30. Still, we are not reached our 15. If you divide 30 by 2, this one is giving us 15. So in that case now, what we have done, you calculate the number of half-lives. So the number of half-lives here we have half-lives here now. This is so we have 240 times a half, because we need the half-life, times a half, 120. This one divided by 2 or times half, 60. 60 divided by 2, 30. That divided by 2, 15. So we are from 240 to 15. You calculate now the number of half-lives. So we have, this is 1, then we have 2, then we have 3, then we have 4. So how many half-lives do we have here in this case? So we have number of half-lives. So we have number of half-lives. Number of half-lives is equivalent to 4. That's what we have. So we are supposed now to calculate the after 6 hours now. After 6 hours, the count rate of this one. So to calculate the half-life period now, we take these hours here. It can be hours, it can be minutes, it can be years. This one here you divide by the number of half-life. Number of half-lives divided by this 6 hours divided by the number of half-lives now will give us the half-life period. So we conclude here that we have a half-life period. Half-life period now is equivalent to half-life period, this one will be equivalent to 6. In this case, divided by 4. This one will be 3 all over 2. And in this case, you have this one as 1 point. So you will be having that one as 1.5. In this case, 1.5 hours. That is how you can calculate now the half-life period. Let us move to our next question. Our next question, we have calculate the mass. So calculate the mass. Calculate the mass of nitrogen 13. The mass of nitrogen 13 that remains from 2 grams. It remains from 2 grams after 1 hour if the half-life period of nitrogen 13 is 10 minutes. So in this case here, we have been given the half-life period. The half-life period in this case we have been given that 10 minutes. So it was from 1 hour, then the half-life period is just 10 minutes. So here we can easily get the number of, in this case, half-lives. The number in this case of half-lives is equivalent to 1 hour is equivalent to, this is the same as 60 minutes. So you take this one as 60 minutes here, you divide it by 10, which is because the half-life period is in the decay after even 10 minutes. So this one is equivalent to, we have this one half-life, the number of half-lives is equal to be 6 half-lives. So we need now to have the mass that remains. So we need the mass that remains, the mass that remains from 2 grams. So we have 2 grams and we want to move 6 half-life periods until we get the mass remains. So what can we have? So first of all, you can have 2. 2 divided by 2, we have 1. 1 divided by 2, that one is giving us a 0.5. So we have this one as 0. We have this as 0.5. So we have 1, 2. Still we are far away from 6. You divide this one by 2. 0.5 by 2 is giving us 0. In this case to 5. We just proceed. So we have 1, 2, 3 up to 6. So this one divided by 2, we have we can have this one as 0. So we have 0.1 in this case to 5. We proceed. This one you divide by 2. So we have, if you divide that one by 2, we have another here. That one by 2 is giving us 0.06 in this case to 5. So we have 1, 2, 3, 4, 5. The last one now we have 6. This one you divide by 2 is giving us 0.031. Then we have 2, 5. So this is, we have 2, 5. So how many half-lives do we have here? So the number of half-lives we have is, this is 1, we have 2, we have 3, then we have 4, then we have, this is 5, then we have 6. It is 6 now because we have the 6 half-lives. So what is the mass remains from 2 grams after 6 half-lives? So the mass just remains to be equivalent to 0.031 in this case. Then we have 25 grams. That is what we have. So we proceed to another question here. So we have that how old is the Egyptian pharaoh in the tomb with 2 grams of carbon-14 if the normal carbon-14 in the present tomb is 16 grams. The half-life period of carbon-14 is 5,600 years. So one of the application of this radioactivity, it is used for carbon dating. So in this case, we wanted to see the how old is this pharaoh. Mnakumbuka huyo farao ni yule mwana ambaye aliambiwa na bibi yake ambaye alikuwa anaitwa Klaudia. Wakati Wayahudi walikuwa na msingizia Yesu, Klaudia bibi yake akamwambia kwamba huyu mtoto wa Mungu ambaye hana hatia. So farao akaamua kwamba kama mtoto wa Mungu hana hatia, akanawa mikono, akaambia Wayahudi, nyinyi mtaamua vile mtamfanya. So alinawa mikono, lakini baadaye alikuja akaaga dunia. Alipoaga dunia alisikwa, na sasa tunataka kuangalia tangu saa hiyo alishakuwa amekufa, amemaliza miaka ngapi on that grave. So how many years? We want to see now how old that Pharaoh is in that tomb. We are not in the church. We can come the mothers of the church later. So here we are now talking of chemistry. So we have now how old is this Pharaoh? So we have 2 grams. So so how old is this one in the tomb with the 2 grams? If the normal carbon 14 present by now is just equivalent to 16. Is just equivalent to 16 grams. So what can we have here first of all? So we have this, we need to have the number of half-lives. So we have, this is, the present is 16 grams. So from 16 to 2, from this 16, then to 2. How many half-lives do we have here? So we have this is now 16, that is 16 divided by 2. This one is giving us 8. 8 divided by 2. So we have this one as 4. 4 divided by 2. So we have now 2. So from 16 to 2 grams. From 16 to 2 grams. How many half-lives do we have? So this is 1. We have 2. Then we have 3. So here you talk of now the number of half-lives. The number of half-lives in this case is equivalent to our number of half-lives is equals to 3. So in this case, if we have half-lives is equals to 3, and if the half-life period is equivalent to 5,600 years, how old? So how old is Pharaoh now? We want now to have the age. The age is equivalent to, you take the number of half-lives, which is 3, times the number of half-life period. Half-life period here in this case is 5,600. So which one? That one will give us now 16,800 years. So this one is giving us 16,800 in this case years. So tangu Farao akufe amemaliza miaka 16,800 on that grave. So a very fine question. Now we proceed. We have 348 grams of 348 grams of a nuclide A was reduced to 43.5 grams. So masi ya kwanza ilikuwa ngapi? Masi ya kwanza ilikuwa 345, ikaanguka up to, that one was reduced. It was reduced to 43.5 grams. So after how many years? After 270 days. So we have the mass was reduced from 348 to 43.5 after how many days? After 240 days. Determine the half-life period of the nuclide. Hii ni rahisi kabisa penye nimewaambia. So you start from 348, you drop a half by a half by a half until you reach 43.5. So we have this as 300 in this case, 0.8. If you divide that one by 2, we have this is 174. Baada hatujafika kwa 443.5. When you divide this one by 2, that one is giving us 87. So we have this one as 87. We proceed. 87 divided by 2, this one now will give us, this is giving us 43.5. So here we have the number of half-lives. So we have 1, 2, 3. So you have 348, a half. So if you divide this one by a half or times 2 here in this case, don't divide it by half, because if you divide it by half, now you can get a different answer. So you just multiply by half, or you divide this one by 2. So this one by 2 is giving us 174. But no, we are far away from 43.5. So you divide this one by 2 again, you get 87. 87 by 2, so now we are getting our 43.5. So here now we need the number of half-lives. So the number of half-lives here, in this case, the number of half-lives is equals to 1, 2, 3. So we have this is the 3 half-lives. And now we need to determine the half-life period. So we need to determine this half-life period, and if the mass dropped after 27 days. So half-life period now from here, just to say this is half-life period. Half-life period is equivalent to, it is now 270, the number of days, you divide by the number of half-lives, and this one is giving us now, you get, this one is giving us 90 days. So we have that one as, we get that one as 90 days. Now, we have the last part. We have 100 grams of radioactive isotope was reduced to 12.5 grams in 81 days. Determine the half-life period. So this one is very easier. So you start from 100 grams, you drop a half by a half by a half until you reach here where we have our 12.5. So what do we have here? So you will have 100, so we have this one is 100. 100 divided by 2, this one is giving us 50. 50 divided by 2, this one is giving us 25. 25 divided by 2, this one is giving us our 12.5. So from 100 grams to 12.5, how many half-lives do we have? So we have, this is 1, 2, 3. So in this case here, you talk of the number of half-lives, the number of half-lives. Now in this case, will be equivalent to number of half-lives here. In this case, is equivalent to 3. Now we need to determine the half-life period. So half-life period here now, you take 81 days, you divide it by 3. As in the case we took 270 days divided by 3, the number of half-lives. So we have a half-life period here in that case, a half-life period. So we have half-life period, half-life period now is equals to P. You take this one as the 1, you divide it by the number of half-lives, and now this one is giving us, 27. In this case, we have this as 27 days. You can see the questions of radioactivities are very, very simple. Easier because you need to do a lot of practice. You use the simplest method that you will be able to understand. And also you will be required to draw the graph and be able to interpret, you calculate the half-life period from the graph. Don't forget to subscribe my channel, watch and share. Thank you for watching.